I get a lot of unwanted mail, mostly in the form of people wanting me to take out a credit card and go into debt. Recall that I railed about that in a prior video. Well, here's a few examples. Southwest Airlines wants me to fly in their planes and use their credit card to pay for it. They will even give me 40,000 bonus points on their Rapid Rewards program if I go into debt with them. American Express wants to get me into debt with the dubious distinction that they want me to pay a yearly fee to use their credit card. That's like asking somebody to pay for using the internet. Then there's my favorite one from Capital One. They have the slogan, "What's in your wallet?" The answer is cash, not your credit card. That's why I have my own big paper shredder here. It's the second one I've owned in the last few years. The first one wore out from shredding all the junk mail I get. The good news is that we're going to do another machine teardown for you. This time, we'll study the large DC motor that runs the paper shredding mechanism. Before we tear down my broken paper shredder, let me demonstrate how the paper shredder works. It's simple. You move the switch to the forward position and feed the junk mail into the paper slot. The paper is shredded by the motor assembly and deposited in tiny bits into the paper bin. If you feed too much junk mail into the paper slot, the mechanism jams and stops. Then you set the switch to the reverse position and the remaining unshredded papers can be pulled out. The safety key must be in place for the shredder to work. You take the key out and store it in a safe place if you want to make sure your little kids around the house don't shred your hard-earned paper money. My kids enjoyed shredding my junk mail when they were little. It gave them something to do when they were bored. Now, I'll shred all 3 pieces of the junk mail I just showed you. Oops, this is an interesting one. This paper is not shredding. Bad news. So we'll use our reverse switch. Pull it out. Then what you have to do is open the letter up, get it into thinner pieces, put it back into the on position, and then you shred the thinner pieces. Boy, this is fun. Now we shred our last piece. Very impressive, eh? Here's a photo of the shredded paper inside the paper bin. Now we have to switch gears a little bit. This is the photo of the motor assembly of my broken paper shredder. I've taken the upper cover off so that you can peer inside. The DC motor powering the unit is in the lower right side of the picture. It is directly connected to a worm gear assembly, which is part of the gear assembly that supplies the 82.5:1 gear ratio that you need to shred the paper. The motor and worm gear are attached to a metal frame, which in turn is attached to the lower cover. There is an AC power board to the left of the motor that converts power from 120 VAC 60 Hz to 90 volts DC. The paper feed assembly is the beige plastic piece at the top with a slot in it to feed paper. There is a paper presence sensor in the center of the paper feed. This sensor detects the presence of a paper being manually fed into the top of the shredder. When the sensor detects paper presence, the motor starts. Here's a close-up of some of the electrical components. The power board is on the left side. You see the usual array of power components, large capacitors, power transistors, and heat sinks, etc. that you would expect in converting a significant amount of AC to DC voltage. On the right side, you see the light source and detector of the paper presence sensor. Here's a close-up of some of the mechanical components. The worm is the slender part with 4 teeth in the lower left corner that is directly attached to the DC motor. It drives the large tan-colored gear with 44 slanted teeth, giving you an 11:1 gear ratio. You can see the black-colored grease at the base of the gear teeth. In the right side photo, you see the gear from the worm gear pair on the same output shaft as the first spur gear. The first spur gear, diameter 0.5 inches, that's 12.7 millimeters, drives the second spur gear, diameter 3.75 inches, that's 95.3 millimeters. The gear ratio of this gear pair is 7.5 to 1. This increases the gear ratio in the motor assembly from 11 to 1 to 82.5 to 1. The second spur gear is attached to a shaft that turns one of the shredding rollers on the bottom of the motor assembly. On that same shaft is third spur gear that drives a fourth spur gear of equal diameter. The fourth spur gear is attached to a shaft that turns the second of the two shredding rollers. There is no further increase in torque with two spur gears of the same diameter. You want the two shredding rollers to have the same torque so that the paper is shred evenly on both sides. Here's a picture of the shredding mechanism, located on the bottom of the motor housing assembly. The paper is fed in between these two evil-looking rollers with sharp teeth. The width of the actual paper shreds is roughly the distance between the fingers of the hard plastic paper guide. This gap allows the rotating teeth of the shredding rollers to chew up sections of the paper. And now we have a special guest for you in this video. Now this is my cat Oliver. Oliver, smile for the camera. Oliver is not too thrilled about this paper shredder. You can see he finds it somewhat interesting, but he's a little bit scared. So Oliver, do you want to eat the shredder? No? Okay, Oliver, one last try. Here's Oliver. This is my cat, Oliver. He's a little nervous. Oliver, smile. There you go. Now you get an idea of how big a paper shredder is. It's a little bit bigger than a cat. Now I've managed to get the motor assembly disconnected from the lower cover, and I'm going to do a series of short videos here that show you how the gears actually turn. So what I'm going to do, because I can't apply power to the motor, is take my hand wearing these rubber gloves because of all the grease on the motor and the gears, and just rotate the back of the shaft, which of course rotates the front of the shaft. And you have this worm attached to the front of the shaft with its 4 teeth, and you have the gear mating with the worm that you can see rotating in the opposite direction. That's got its 44 teeth, hence the 44/40, 11:1 gear ratio being produced. And then on the right side of the gear for the worm gear pair, you see the other spur gears, and we're going to show you how those work in a minute. Here, I'm going to put my finger on the gear of the worm gear pair. It's more efficient to get the gears moving. And you've got the very small spur gear on the same shaft as this slanty gear of the worm gear pair. And it is rotating the very large spur gear behind it. And that was the one with the roughly 7.5 gear ratio. So I'm still using my rubber gloves and rotating the gear of the worm gear pair. And now what you can see is the very large spur gear is on the same shaft as the third spur gear, which is rotating in the same direction. And it is driving the fourth spur gear, rotating in the opposite direction and actually in the same direction as the gear of the worm gear pair. Every time you change direction twice in gearing, you go back to the same direction. And what we'll do next is demonstrate how the actual rollers of the shredding mechanism work. Recall those rollers are attached to the third and fourth spur gears. Now I've flipped our motor mechanism assembly upside down, which means that you're actually looking at a bottom view and you're looking at the roller shafts. And that means that because I flipped it upside down, the motor is actually on the right side instead of the left side. And also because it's an 82.5:1 gear ratio, I'm going to have to really rotate a large angular distance on the worm gear for you to be able to see anything on the shafts. But now you can actually start to get a sense of how paper shredding really works, because you've got these two paper shredding rollers, each with about 25 of these teeth that are taking this poor paper that's in the middle and sticking teeth in it and shredding it into little bits. Now I've managed to get the shredding process going here because I fed my script in, and you can see, at least in slow motion, how the paper shredding process works. Here's a picture of the motor mechanism components. I tried to get most of the grease off of them so you could get a clearer picture. The 4-tooth worm is mounted directly to the DC motor shaft. It mates with the 44-tooth gear for an 11:1 gear ratio. The motor faceplate has 5 holes, 2 of them used to attach a pair of threaded rods through the motor assembly and out to the motor backplate. The other 3 holes attach the motor to the metal plate shown in the video. An integral mounting shaft connects the 44-tooth gear for the worm gear pair to the first spur gear. That first spur gear drives the 3.75-inch diameter second spur gear for a 7.5 to 1 gear ratio, giving the whole system an 82.5 to 1 gear ratio. The second spur gear is mounted to the hex shaft for the first shredder roller, which also houses the third spur gear. The third spur gear drives the fourth spur gear, which is attached to the second shredder roller shaft with an E-ring. I disassembled the DC motor, cleaning away grease and paper fibers to give you a better view of the components. The first thing we see upon inspection is that we have a permanent magnet DC motor on our hands. There are 2 semicircular permanent magnets bonded to the inside of the steel housing, a very low-cost way to manufacture a stator. The outside diameter of the armature barely clears the inside diameter of the magnets, which creates a very intense stator magnetic field. I thought earlier that the worm was assembled to the stator shaft, but now I see that it's machined into the end. This is another low-cost way to build the product. This motor has a small plastic cooling fan attached to the motor shaft with a C-clip. The armature circuit board is mounted to the rear plate. Just to see how strong the permanent magnets were, I put the blade of my screwdriver inside the motor housing. The steel blade was instantly attracted to one of the magnets. When I let go of the handle, the screwdriver didn't move. This photo shows a side view of the armature assembly. It looks a lot like the schematic models we showed a few videos ago of the armature of a brushed DC motor. I suppose that's a good thing, given that a permanent magnet DC motor has the same armature design as a brushed DC motor. You see the armature windings at both front and rear ends of the motor, with the commutator windings and carbon brush assembly in the rear. Here is a close-up photo of the commutator assembly at the rear section of the motor. The gold-colored carbon brush housings position the brushes inside 180 degrees apart and slightly radial outboard of the commutator windings. About 2/3 of the commutator windings are covered with black carbon rubbed off from the brushes, a sign that I got to use my paper shredder for 4 years before it broke down on me. Here is a close-up photo of the commutator circuit board. I took the carbon brushes out of their housings, which is why they're floating in the air now. Normally, they are inserted in front of the compression springs in the brush housings so that good contact pressure is maintained with the commutator windings. Thick copper wires are directly bonded to the brushes. These wires exit the board through the connector on the lower left, headed for the circuit board housed in the lower cover that drives the DC motor. The 250 volt 7 amp fuse is also connected to wires on the connector, guarding the motor against dangerous current overload. A pair of 250 volt ceramic capacitors are wired between the brush housings and the rear plate, which is connected to ground. The motor brushes produce sparks, which cause potential electrical noise to interfere with neighboring devices. The ceramic capacitors absorb much of that noise first. Let's recap. We tore down a paper shredder and learned that it is powered by a permanent magnet DC motor. Obviously, you just learned one application for such a motor. In the next video, we will teach you a more general way to specify a DC motor.